and welcome to the second episode of How to Code That. Today we're gonna learn how to make a 3D background that we can totally imagine like being in a landing page or like in your portfolio or something. Like you can imagine having this 3D background, and then when you scroll under you have some text that can appear, so stuff like that. So to do this exercise, you're gonna have to know the basics of JavaScript, HTML, CSS, and we're gonna use Three.js, but we're really gonna use the basics of Three.js. So even if you're not familiar with it, you can still, I think, make this tutorial pretty easily because we're gonna learn together really the basics of it. Before starting, all the links are in the description, so you can have the link to this demo so you can try it out. You also have the link of the template that we're gonna use for the exercise. And if you support my channel on my Patreon, you can get access to the code of the final demo. Okay, so the purpose of this exercise is to add the 3D elements inside a web page. So we're gonna do that using the Three.js library. So the Three.js library is a really powerful WebGL library that can easily make you add like a cube or like a sphere in the scene, like with just like 3 lines of code. So that's super convenient, especially if you don't really know how shaders works and how WebGL work. I think it's a good way to start, start coding in the 3D world. So yeah, we're gonna really just use the basics of it and add like some different shapes. We're gonna make them rotate. We're gonna make them scale, so it's like have a nice dynamic effect. And we're gonna also play with the camera and text. All right, so let's begin. To start this exercise, we're gonna have to download the Vite3.js template. Okay, so this template already is including CSS like Sass compiler, JavaScript compiler, and the Three.js scene with some stuff inside. So we already have like a basic Three.js scene that we're gonna play with. Okay, so you can clone the repo or you can just download it. Then I'm gonna extract it. Cool, and then here my text editor. In your text editor, just open the folder that you just downloaded. So here we are just opening the folder that we downloaded. Okay, so once you have downloaded the template, go to your terminal, go to the root of your project, and then run npm install. Right, and then npm run dev. Just click on the link that is showing, and you should have that already. All right, wonderful. So if you don't have that, just pause the video and be sure you manage to download the zip and have this displaying in your browser. So now we're gonna see what we have already. So we have a bunch of stuff that are compiling, that is compiling our code. Sorry. We have an index.html file where we have our HTML. So this, for example, the footer, and we have the most important part, the canvas HTML tag. That's where we're gonna put all of our Three.js scene. So everything you see here with the sphere is inside the canvas. First of all, I think we can just remove the footer because we won't need it, right? Okay. Then we have some CSS file, just to have like a font, colors, and stuff like that. Really basic, but we're not gonna use it for this exercise anyway. Then we have a public folder with a texture that we are loading to our sphere here. And the most important part, the JavaScript. Basically, we are creating a new scene. We have our component. Our component is a scene. I'm not using any framework, so that's just JavaScript-oriented object. And we have here our main scene class that is, so our scene. I don't know why it's called main scene, but anyway. And so basically everything that for Three.js runs in there. Then we have a bunch of stuff, a loader manager that is gonna basically load the texture, load font for us, We have some utils that we're not gonna use. GLSL we're not gonna use it. And yeah, okay, so I think we can explain what's going on here. Okay, so first of all, here you can see we are importing some Three.js stuff, some stats, and some little GUI and a loader manager. So stats is just a library that is showing you the FPS. So you're just making sure you're not doing bad things in your code, and you make sure like everything is running at 60 FPS. So frame per second. Then we have our little GUI. So that's this little thing that's easy, help you tweak some values. So you can easily tweak values in your 3D scene just with this slider already there. And yeah, then it's Three.js. So let's start. Okay. So first of all, in a constructor, when we init the scene, we are using a canvas. We are selecting this canvas tag using the class, right? So here we have our canvas, and then we can finally init. What's going on here is that we are waiting for our loader manager to load the image using await and sync. So that just means everything that is below await are being read after this are finished downloaded. So I'm just basically saying load that first, and once this is loaded, init the scene. So setStat, it's a method. Don't worry about that, it's just displaying this. Then GUI same, but for that. And then we have the setScene. I think we should start with setRender first. Anyway, so as you can see, I already described everything here. But how Three.js works, first you have to create a renderer using new WebGL renderer. So everything is in the doc here in Three.js. Feel free to read it if you want, pause the video and read it if you want. It's kind of like complicated because there are a lot of options, but here basically just creating the WebGL context for us. So this is native WebGL, but anyway, we are not gonna go too much into detail here. But basically you just put your HTML tag. So here our canvas that we selected here, and we're gonna put anti-alias true. That's just making it less pixelated, basically, for the lines. Okay, then we can create our scene. So scene is just a Three.js object. As you can see, what is great with scene is you can add any background you want. So here we are using a white color, but you can change the color here. So in Three.js, every time you're using a color, you have to use a 0 and X. Not all the time, you can use different ways. You can just write the color itself like that. It's working as well. But here we're gonna use the color that we're using in the CSS maybe. You can also load an image to have like an image background. But here we're gonna just use a simple color. I think we're gonna use the colors, this color for example. Okay. It's not a string, it's a number, so it's like that. Okay, here. So here we have that, but it's the same color as the text, so it's doing a weird effect. Kind of doing like a clip mask effect, which is pretty cool, but that's not what we want to do. We just want to change the color of the title, so for that we can go there, and here let's use our var. Okay, cool. Better. So as you can see, you can change the background of the scene. The scene is just a 3D object where we're gonna add everything we need. And it's also gonna be used by the renderer. All right, so then the important part as well, the camera. So basically we're using a perspective camera. A perspective camera gives you perspective. So as you can see, it's gonna be, how to say that? Like if you look directly, that's gonna be straight. If you look at a really long way, the line is gonna be closer and closer. like in real life, basically. So for that, you have some parameters you can tweak. So the aspect ratio is always the aspect ratio of your scene here. So here the width is the width of the window, and the height is the height of the window. You have the field of view is how strong the perspective will be. So here if I put the field of view really strongly, see, so first of all it's far, and then it's really deformed. I don't know how to say that. Usually you can put it to 45, but 60 giving you a little bit more depth, so it's interesting. Near plane and far plane, basically near plane is at what time do you want to render things. So if you want to render things, only things that are like 1 unit away from us, we just put near plane 1. So that means everything that is 1 unit close to us, minus 1 unit, less than 1 unit close to us, will not be rendered, and it will just disappear. And far plane the same thing, but for things that are very far. So here we don't really care because we are not gonna have things really close to us. Maybe we can put it to 0, 1. I think it's great. And these are the position of the camera. So we are saying the position on the y-axis here. So as you can see, the green thing is the y-axis. The x-axis is the red, and the z-axis is the blue. So we want the camera to be here. I think we want to reset the camera. So we want to put the camera to 0 in x and 0 in y. So 0 in x will be like that. But we are still a little bit above. So we want the y to be 0. That way we are really like it should be, like the default view. And then we have to put the camera away, otherwise we're gonna see nothing. So we want to put it far in the z axis. So probably, yeah, 20, maybe it's too big. 10, I think is great. Okay, 10. Cool. And we are saying, look at the center, basically. Okay, so then we have an orbit control. An orbit control is an object that is made by Three.js that is giving you the fact that you can use your mouse to rotate. That's where we are doing since the beginning. Like here, I can click, rotate. So that's really convenient to debug, to do debugging stuff. So you can just check. You can also zoom with the mouse. So that's pretty convenient. Okay, then we have the axis helper. So that's axis helper is just this 3 color stuff. So we are not getting lost, like where is the Z, where is the X, basically. Here we have a method called setSphere. So this is creating a sphere. So that's what we're gonna do for this exercise a lot, is just create new geometry and like display them. So that's basically what we're gonna do. Any object in Three.js is composed by a geometry. So I would say the skeleton of the object and a material. And the material, I would say the skin. So imagine you have a skeleton, but then you can change the skin. Could be blue, could be red, could be like a texture, could be a lot of stuff. Could be like custom shaders when you're doing crazy effects on it. Once we have the geometry and the material, we create a mesh. And then we have the mesh already, and we can just add the mesh into the scene, just using scene add. Here, if I remove the mesh, it will not appear. All right, so we'll see that later. Then we have the set stats, set GUI, we don't care. Events, in the events, we are calling a request animation frame function. So this function is being called 60 times per second, depending of the lag. And so that's pretty much it. And inside of it, we are updating the orbit control. It's not really necessary, but here we are doing it. And we are updating the renderer. So the renderer, remember, is the first object. It's the most important thing. And here it's basically the WebGL context. So we are saying render the scene and the camera. And finally, when resizing, you have to always update the camera aspect ratio. So update by the width of the window and the height of your window. Then do an update projection matrix. I think we don't need it here. Well, anyway. This is for Retina displays. It's basically increasing the quality of your device. You can see that in the first episode also. And this is basically updating the renderer size. So you have to update the camera aspect and the renderer size every time you are resizing your window. Okay, so I think that's it. We can start the exercise. Now we explain how Three.js works basically. Okay, so the first thing that we're gonna do is that we're gonna create a new component. A component that will represent any shape that we're gonna add. And we're gonna add multiple shapes through our scene. So basically, we here just want to create a new class that we're gonna call shape, for example. I'm creating a new class. We're gonna export it so I can use it in another file. So export default class, and we're gonna call it shape. Cool. Then we're gonna have a constructor. So that's the first method that is called when you create a new class. And inside of this constructor, we're gonna give it multiple things. So as we can see already, we can go, for example, to the sphere geometry to see how a mesh is done. I don't know how to write sphere. Okay. All right. So as you can see, a sphere is created, is made using sphere geometry and any material. So the skeleton and the skin, and then you create a mesh. So we're gonna basically pass a geometry, a material, and we also gonna give the scene, so we can add our mesh to our scene. Okay. Or if you, maybe the parent mesh, if you want to be, if maybe that makes more sense, I don't know. Okay. So here, what we want to do is we want to use the geometry and the material to create a mesh. So we're gonna create this mesh that will represent the mesh of this class. And we're gonna create a new mesh. Here I'm importing mesh from Three.js. New mesh like that. And we're gonna add the geometry, then the material. What I'm doing right now is abstract, but you will see later. And then we're gonna add this mesh to a parent object. Okay, so that's really the basics. And here in our scene, we're gonna not call set sphere, we're gonna create set shapes. And we're gonna replace the set sphere here. You can remove the comments if you want. And here we're gonna first create a container mesh. The reason why is because we're gonna put all our objects inside our container mesh, because then we're gonna move our container mesh using the mouse. So that means you can move all of the objects. It's kind of like using a group layer. I don't know if you're familiar with like Photoshop or stuff like that. And basically we're just gonna move the whole group. So we're gonna do something like that. Container mesh. And we're gonna do a new object 3D. So object 3D is basically, you can guess that as an empty 3D object with no geometry, no material, but it's still an object. It's just that it doesn't have a skeleton, it doesn't have a material, but it's an object and you can add other objects in it, like a group layer, basically. All right, so now that we have that, we can create a new shape. So we're gonna call it shape 1. is going to be a new shape. So the class that we just created. And here we're gonna add so the geometry. So the geometry and the material are there. Geometry. Oh, sorry, it was an object, right? Because I created an object here. So it's easier than if you have a lot of parameters. I subject you to always use objects in functions parameters or class parameters. So here we're gonna put our geometry and our material and our scene, or parent mesh, sorry. Parent mesh will be the scene, right? So we don't need that. And here, we're gonna call that geometry 1. So geometry will be geometry 1. And yeah, I think I'm gonna reduce that. Anyway. And material, material should be written like that. But it's just a shortcut in JavaScript. You can just do that. It means, so that property here is this property. So yeah, let's do that. Okay, so basically we are giving the shape the geometry 1, then we are giving the material here, and then as param mesh we are giving the scene. And I think that's just enough to. Okay, something is wrong. We are creating the ship. Oh no, we're gonna add the container mesh first, and then, because we have our container mesh here, we need to add this container to the scene, because we are not adding it to the scene, first of all. Okay, and then looks like I'm getting an error. Geometry 1, material, shape. Let's see. The issue is just that I was not importing the correct shape. So you have to here import shape from what we created here. So just showing you the import. So the import is like that because we are importing the shape here. Okay, cool. So it's working great. We have our shape, but now it's created in our shape component, which is what we want. So that's perfect. Okay, and we can also now create an array that we're gonna call shapes. I think honestly we can move this to the top of our class. I think it's just cleaner that way. And this is going to be an array, and here we're gonna basically just add our shapes. We're gonna use the array later on. Okay, so we have our first mesh, which is great. But now, first of all, I think we want to change the position of it, right? Maybe. We're gonna give it a position. So if you want to give it a position, first here, we're gonna create a position parameter, and in the parameter here, we're gonna just, whoa, sorry. Don't know what's going on. Okay, position. Then we're gonna do this mesh position, copy the position we're gonna give. So that's how you can position stuff in Three.js. And the position in Three.js is basically a vector 3. We're gonna do new vector 3, where we have our, okay. So here we're gonna just position the coordinate of the, like where the shape will be. I think it's based on the center already. And so basically if you put 0, 0, 0, it's gonna be in the center, right? And if you move it like, I don't know, like 5 units on the x axis, sorry, it's gonna be like that. So maybe we want to make it like a little bit on the, like that on the right, and a little bit above, like do anything you want, really. So feel free to be creative and just, if you're making a landing page, create any shapes you want and add them at the position that you want. Cool, so now it's kind of like static, right? Nothing is happening. It's kind of sad, right? So we probably want to make it move. So we can make it move like in the y-axis, for example. So to do that, we're gonna create here a method called render. And in this method, we're gonna update the position of our mesh. So, okay, so here what we can do is we can say, position it to -2. Okay, we are not calling that yet. So here what we're gonna do is we're gonna create an array. We're gonna use the array. Remember, this is where we are render everything at 60 frames per second. So here we just take our array. We're gonna loop through our array like that. Okay, and then so that's the shape. So for each shape, we are calling the render function of each of our shapes. So here, as you can see, it's working because it's calling this. So this is called 60 times per second, but nothing is changing, right? So something we can do is that we can make it move up and down like that, up and down, up and down. So to do that, we gonna use something really convenient for that in mathematics called sinus. So sinus, basically, it's you're gonna put any value inside your sinus function. So this is called like that, math.sin. And here, any value that you're going to put will result between -1 and 1. So it's gonna be a wave like that. So if you put inside this value an increasing number, so a number going from 0 to infinite, it's gonna always go up and go down like that. So it's gonna, even if it's like 1 million, it's still gonna be between -1 and 1. And it's gonna do that in a wave like that. So here, what we're gonna do is we're gonna add a value that is increasing through time. So, which is great because when using request animation frame, you can actually get the current time, like since when you started the web page, from where it is right now. So you're basically giving a time in a millisecond. Here, it's just a parameter that is already here. We can call it time. And we're gonna use this value to put it here. So this value will be from 0 to infinite. And we're gonna use this value here. And here in the shape, we're gonna put it here. Okay, so as you can see, it's working. It's going from -1 to 1, but it's like, okay, just don't look at that if you're epileptic. Like, I'm gonna just stop it right now. Okay, better. So here we're gonna just need to give it a frequency. So the frequency will be how fast this time will increase, basically. It's not really a frequency, actually. It should probably just be a speed. But we can say frequency, I guess. So here we're gonna need a frequency. And the frequency that we're gonna use is, for example, that one. Okay, that's way too strong. So maybe 0.1. Okay, it's better already. But it's still going a bit fast, right? So maybe that way. Okay, cool. So we have something moving slowly up and then down, and it's infinite, right? Okay, so this value will always be from -1 to 1. You can log it if you want in the console log. You'll see it will always be from -1 to 1. So now that we have that, I think we can probably now add our second shape. Okay. So now you can be creative and do any shapes you want. Here you can get access in the Three.js doc. You have a lot of cool geometry that you can use. Like you have a box, like you have capsule, like a lot of geometries. So that's pretty cool. We're gonna start, I think, with the torus. I like the torus, it's pretty fun. So yeah, let's add a big donut inside of our landing page. Okay, so we're gonna go to our stage shapes. Here, as you can see, we're using, okay, I'm gonna talk about the material just after, don't worry. But basically, we are using a texture that we are loading with the loader manager. Here, this is this texture. Then I'm gonna explain what it's doing. Because it's just not using it as a normal texture, it's a matcap texture, which is great for what we need here. Okay, so then we're gonna create a new shape. I'm gonna call it shape 2. But this time, we are not gonna use our sphere geometry here. We're gonna use, so this material, we're gonna keep the same material. Know that you don't need to create another material for each mesh you're creating. You can just give the same material to all your meshes and they will look, it will improve the performance, first of all, and it's gonna work. You don't need to create a new material anytime. If the materials, if the color should be different, then in that case, create a new material. But otherwise, just keep the same. And here, we're gonna use the same material all the time. Okay, so here, we're gonna create a geometry, but we're gonna create a torus geometry. So we're gonna just use what Three.js are telling us in the doc. And we're gonna add our geometry 2 inside of it. And here we can basically copy and paste. Okay, so here it's Three.js geometry. So I'm just import it here. I'm importing the torus geometry, as you can see, from Three.js. Okay, and then we have our geometry 2 and our container, and we can also add it to our array so we can make it move. All right, so let's see. Oh wow, okay, it's just a giant donut. Okay. Okay, that's great, but we probably make it smaller, right? So to do that, we're gonna just look at the properties. So here we have 4 properties. So the first is the radius, then is the tube. Tube is the radius of the tube. Okay, so we probably want to make the radius smaller. So I don't know, like 3. Okay, so we made the radius smaller, but we didn't change the radius of the tube. The tube is here. So probably 0.5. I don't really like it like that. I think we can increase that. Yeah, it's better, right? Or maybe just make this smaller and this 5. Yeah, feel free to do whatever you want. Okay, I think it's great like that. Cool. Nice in the center though. So yeah, and the 2 other things are the segments. So usually don't change the segments. It's basically how many vertices, how many polygons you are created. I think here we don't have a lot of polygons, so I think that's great. You can always tweak the value here, by the way, if you want to see how it looks like before doing that. Okay, so I think we have a good number of segments, of polygons. 116, okay, great. Okay, so we have our shape, but we probably want to change the position, right? So probably we want to make it here, really on the left, and maybe we can like make it closer to the camera, or maybe further. No, further is like that, I think. No, that's, sorry, that's the y-axis. Yeah, we can put -2. It's not changing anything because, okay, and here maybe. Feel free to position it where you want. Here I put it in the z-axis like that, so it's a little bit behind. Okay, great, so it's working, but the two shapes are synchronized, right? So we probably want to give them two different speeds. So for that, we're gonna change, we're gonna call it speed in the end. So we're gonna add a property here called speed. And here we're gonna just say this spin equal to spin. Here I'm not using TypeScript, but I recommend using TypeScript for big projects, so you can directly give all your properties, what type of properties are they, and so it's gonna kind of like save you time and make your cleaner code. But here, just for a demo, we don't need TypeScript. Anyway, so here the speed, we can say that the default speed is this value, right? Because I think we like these values. So we can just write it equal like that in your parameters. So that would be the default value. And here we're gonna use the speed. So here we are just saying the speed by default is this, but you can change the speed by giving it to the class here. So here we can say, on the second, we can make it, I think it was 002. Okay, so as you can see, now it's desynchronized. So I think it looks better. You can always add an offset speed. Should I do that? Well, anyway, basically you can add an offset speed. And so it will not start at the same point. Yep, sorry. For that, you just have to, yeah, so, okay. So for that, you just have to add the offset speed to that, and the default value will be 0. And here, for example, if we add an offset speed to 10, sorry. Okay, see, as you can see, starting, it's not coming at the same time already. It's kind of like different like that. Okay, cool. So I think that looks great, but it's kind of like, I don't know, it's missing something, right? It's missing, I would say, a rotation. So let's add a rotation for the donuts, because right now it's not looking great. So to rotate an object in Three.js, it's really similar to the position. Here we are moving the position Y, but we can do the same using the rotation value. And here, if we are changing the rotation Y, that means we're gonna change the rotation on the Y-axis. That means, imagine you have like a line like that. Here's the donut, and we're gonna make it turn like that on the Y-axis. X-axis will be turned like that, and Z-axis will be turned like that. So let's make it rotate. So to do that, first of all, you have to know that rotation in Three.js is not in degrees. Sadly, it's using radians. Sorry. So you have something in Three.js that you can call, I think it's in the math utils, and you can have like dec2rad function if you want to do the translation from, I don't know, like 360 degrees to radians. Or if you're a boss at math, you already know how to play with the p value and the radians. But here we don't need that, because we're gonna increase the rotation in the infinite. So we're gonna increase the rotation, and it's gonna be just like infinitely, basically going to turn in one direction, and it's gonna make around. So here we're gonna add 1, for example. Just remember that this is in radian, and this is 60 times per second, so maybe 1 is a bit fast. I don't know, let's try 0, 1. Okay, 0, 1 is already pretty fast. So we're gonna probably say 0, 1. Okay, I think I like it. It's kind of slow, but I like it like that. Here we are applying the rotation to all the shapes, but we don't really mind, I think. Okay, and then we can do the same thing, but in the y-axis. So it's kind of creating this effect, which I like. And we can also, let's say, apply a rotation on the z-axis. Cool. So now we have something pretty cool for our landing page. So you can imagine here you can scroll and then you have other stuff. You can also fix the canvas scene and make text appear. And you can also animate the 3D object as you scroll. You can do a lot of stuff with that already. I'm just giving you the basics. But I think it's already looking great. And like, as you can see, Three.js is super easy to just start with and start shooting 3D in the browser, which is amazing because native WebGL is really complex. So yeah, and if you don't know about shaders, here we are not even using shaders, so that's pretty cool. Three.js is doing all the thing for us. Okay, so now that we have that, I kind of need to explain what's going on with the material, maybe. Okay, so also I'm gonna remove this axe because I think it's ugly. Okay, it's better, right? Way better. So yeah, so what's going on with the material here? We are loading a texture and we are applying what we call a mesh matcap material. And then we are giving the material to our skeleton. So what a matcap is, it's like, as you can see, I didn't add any light to the scene. And curiously, you can see that we almost there is a light, right? It's kind of like magic. We have like a kind of like the shadow, like it's darker here in the bottom and lighter on the top. So basically that's what matcap are doing. Matcap material is like creating a fade light. So you don't have the heavy calculations that you would have if you add a real light into your scene. And so it's like super optimal if you want to kind of like add more depth to the scene and that. For example, I'm gonna show you, I'm gonna use just a basic material and I'm gonna say, because it's color, you have to put a color and we're gonna do new color, blue, for example. Okay, as you can see, it's super sad, right? So if you want to, you can also add the texture, but like, okay, we can also try to do that and use here the texture. I'm thinking don't want to lose too much time on that. I think it was, wait, what was it again? Yeah, you have to add, yeah, let's do that. Texture. Okay, so here we have a texture. Okay, the UVs are bad, but anyway, first of all, it's weird, and then you don't have the light effect, as you can see. It's always the same color. No darker path. But if you're using matcap, then you're gonna have like fade light. So that's pretty much what we want here. Okay, so this is great. We have our stuff happening. And I think now we can add a third shape. Why not? So let's do that. So let's see, what do we have? We have cone, we have decahedron, we have cylinder. I think I like cylinder. Feel free to pick any shape you want and just see how it's made. So here, cylinder, it's using a cylinder geometry. Okay, so let's try that. So for our third shape, we are going to use, sorry, a cylinder geometry. So same again here, I importing it. Thanks to VS Code, I can just do that. But I'm importing the cylinder geometry from Three.js, so it's that. And here we're gonna call that geometry 3. We're gonna put it here, add it again to our array, and let's go. Okay, so we have our cylinder, but it's just giant. So, okay, so here we have the radius top and radius bottom. Here we have the radial segment and the height. So I think we have to change the height, so the third one, because it's like 20 is a lot compared to what we have here. So probably 4. Okay, 4, it's kind of big as well, probably 2. Okay, and then we want to change that thing. So maybe 1 first. Okay, and 1. Okay, that's more something that we can have to, but I think I want to do like kind of like a conic shape. Yeah, I think I like this shape. Okay, perfect. And it's perfectly in the center because we are just giving it the same parameters here. But let's change that. Let's put it in the center and let's put it in front of the camera. Okay, maybe not too close to the camera. Okay, so here you can see it looks like. I think it looks pretty great. We can also change the speed. We can make it slower and change the offsets. Okay, so now we have something really desynchronized. So I think it looks better, right? I think it's a little bit fast, you know. Yeah, okay. Feel free to do whatever you want, add any objects. You can also add like models, but we are not gonna see that in this tutorial, otherwise the video will be like 5 hours. So, I mean, not 5 hours, it's not that complicated with Three.js, but anyway, I'm gonna do a new tutorial for that. But yeah, you can imagine having like a 3D cactus or whatever you want, like something that, I don't know, that works for you and to your portfolio really easily. Okay, cool. So we have that. And I think we have something great. And I think now we can start to begin the last part, so the 3D text. Because here, as you can see, we have some text above, but what if we could write text inside of it? Okay, so let's go. Okay, so to create text, we're gonna use what's called a text geometry, which is really convenient. It's already doing what we do. Okay, so you have different ways of writing text in 3D. The best thing to do if you're using like flat text, but in a 3D environment, is to use MSDF. I'm gonna do a tutorial for that, but it's pretty complex. Like it's you have to know about shaders and stuff like that. So this is like a different level of skills to do that. But here we kind of wanted to make it 3D with what we call an extrude shapes, extrude geometry. So for that, we're gonna use text geometry from Three.js, which is really convenient for that. Okay, so as we can see here, we can create what's called a text geometry. Okay, but here we need to load a font first. So here it's using the font loader from Three.js, and it's using, look at that, it's not like a web font, right? It's not a TTF file, it's not a it's not an OTF file, it's a JSON file. So that means we'll need to convert our TTF file to JSON file, but don't worry for that. 3JS is explaining that you have something that you can use. So there is this website, and you can just select your TTF file, so your true type font, and you can just convert it for 3JS. Okay, so first of all, yeah, where was the... okay, it was there. Okay, but first of all, let's add the geometry just to see. So first of all, we're gonna create... I should stop saying first of all. We're gonna create a new method called setText. And we're gonna put it under the shapes. Feel free to organize your code, of course. That's just for a small tutorial. But otherwise, I wouldn't do that. I would probably do that in the framework as well. But anyway, here it's doing that faster. So, okay. We want to use a text geometry. Text geometry, as you can see, you cannot import it directly from 3JS. You have to use this import. So you just have to import this. I'm not sure we need to install the add-on. I think it should be there already. Well, okay, I know that you can just import it using the 3JS example stuff though, so that's what we're gonna do. Just checking. But basically here you can just import it like that. So feel free to pause the video as usual and write this. Okay, I know this is working, so we're gonna use that. Okay, and we're gonna create that. So as you can see here, we first need to load a font, but we don't have a font. Okay, so let's create one. So for that, you can just use any font you have, any TTF font you have. But here, for the example, we're just gonna download the Google font because they are free and they are pretty cool. So here I'm gonna use, for example, the Roboto slab. I think this one is great. So the Roboto slab that I have already here is the one that I'm using. And so we can just basically download the file. Here, we're gonna put this inside of public. You know, that's the folder when we put our images and public assets. And we're gonna create a new folder called font. And inside of it, we're gonna add our font. We just need to extract it. Okay. And now let's see. So we should have now, so feel free to pause the video, download any font that you want. You can also use the Roboto if you want, but that's up to you. Okay, so here as we can see, that's the file that we want, right? It's the TTF. So we're gonna, first of all, use this website. So here you can find this website here in the 3JS doc. It's this link. So now that we have that, we can just selection our file. And we're gonna add the TTF file, right? Okay, now we just have to convert it. Cool, and we're gonna call it Roboto, just Roboto slab, something just more simple. Slab. Okay, so now let's check what is this file. Okay, so as you can see, that's the JSON file, which looks really complex, and actually it's pretty crazy because what just this website did is basically took any characters of our font and it's created a 3D geometry from that character. So with like the position of each vertices, so each polygons, I would say, for each character. And it's then giving you that to a JSON file, so it's super light file, just giving you the coordinates of each letter, basically. So that's kind of complex, but it's doing it for us, so that's perfect. And now that we have that, we can just use it inside of Loader Manager. So in the Loader Manager, I've did something for that already. I'm using the font loader already, so you can use it in the exercise. And you just have to do this. So here, we're gonna add a new asset. We're gonna call it Roboto font, for example. And we're gonna say it's a font. And the file we're going to use, now remember, we put it here in font in our public folder. So when we are doing that, we are calling our public folder, and the public folder, we have font, and then we just have to copy this, and it's a JSON. Okay, so this is loading the Roboto font for us already. So once we have that, everything that we load in the Loader Manager will be in Loader Manager.assets. The name of it. So it's basically like that, but we need to call it font, I think. Okay, so here it should be the name that we called. So I think it was Roboto Slab. And then, yeah, I think that's, let me just check if we need to, yeah, we have to call font. So I'm not sure because I'm changing my Loader Manager from project to project, so. Okay, here we have the font. Here we have our text. So here we are writing hello 3JS, but you can write everything you want. And so we have our geometry, and we're gonna do as usual. But remember that we have to call a material first. We could use this, but I'm gonna just use a normal, just a white color. So for that, you can call basic mesh material. It's basically just the simplest material you can find in 3JS, and we're gonna call white. Again, you can choose a color like we did here, but here I'm gonna use white. Cool, so we have that. We have to create a mesh, remember, new mesh, and we put our geometry, and we put our material. Simple as that. Then again, we probably want to add this to our, we can add it to the scene, but we here for the purpose of this exercise, we're gonna add it to the container mesh and do mesh. All right, let's see. Okay, so that's just here. It was not slab, it was font, sorry. Okay. Yes, sorry, and I forgot the new. All right, cool. So as you can see, we have nothing. Oh, we have something, but it's just giant. So as you can see, we need to change the parameters because this is just giant. Also, we can just remove this, right? We don't need this anymore. Okay, so let's change the parameters. So here we can see we have a lot of stuff happening. I'm gonna reuse my presets, but basically we don't need these. The size can be, I guess, smaller. Okay, that's still pretty huge. I think that's because of the height, probably. Height is really big as well. Okay, let me see what parameters would work. Feel free to play with the parameters, and depending on the size of your scene, it will change. So here, let's see what I've used in the demo. In the demo, I used these values. Okay, we don't need the bubbles as well. Okay, great. I think it's better. As you can see, it's 3D. You have like a, you can see there is like thickness. To increase the thickness, you can increase the height. You can see it's thicker. But here I think 0.1 was great, depending on what we had. Cool, so we have our thing, and you can say welcome, or anything you want. Welcome to my portfolio of, yeah, basically anything. Here it's ugly because it's not centered, right? So we probably want to center it. So to center it, you have tools. So I'm gonna show you. So first of all, we're gonna have to do what we called a compute bounding box. So compute bounding box, basically, it's like checking your geometry and it's saying, okay, what is the biggest, like it's creating a box around your geometry. And it's like, what is the bigger range? Because we're between what's in the minus x-axis and the plus x-axis. So what's the biggest range of your shape? So if your shape is that, for example, then this length will be like the bigger range. So this is giving us the bigger range of the x. It's also doing it for the y and the z axis, but here we want to center it. So we just want to move it on the x-axis from the center. So here we just have to do the max x minus the minimum. So we're just basically giving it the whole range. Then we need the whole range. We don't want to move it from the whole range. We want to divide it by 2, right? So here you can just, I think it's not clear like that. I think it should be better like that. You divide the range by 2. So you divide the width basically by 2. And then you offset it on the left. Okay, I'm getting an error. Okay, it's not mesh, sorry. It's the geometry that we're using. Of course, and I said that, so same here, right? Okay, here you go. So it's centered, perfectly centered. I think the sphere is going inside of it and the donuts as well. So let's tweak that a little bit. Yeah, I think we can move the sphere on the, put it in the front or in the back, maybe in the front. No, sorry, again. I don't know why I messed up with that. 2, I think it's great. Okay, so it's in front. And the donuts, maybe we can put it, the torus, -3. And I think we don't really see the welcome. Maybe we can make it bigger. I think that's better. Feel free to tweak anything you want. And maybe this guy, we're gonna put it and not like that. Okay, great. I think that's looking great. What do you think, guys? So you can have that in your landing page. Then I could also change the position, because here the positions are always from -2 to +2. So for that, I can basically, yeah, I forgot to do that, but basically we want to save the init position. So the initial position is what we are giving here. But here we just need to add this value to the y position that we want to put it. So the y position, because otherwise it's gonna always be between -1 and +1. But we basically, for example, we can offset it from the 1. Okay, so that's working, because now this was basically not working at all, because I was just saying position y is always equal. But now that I'm adding the initial position y, then we can have these offsets. All right, I think that's better. Maybe this guy is a little bit too down. Okay, I think that should do it. Feel free to do whatever you want. And yeah, that's it. We have a nice effect like that. Okay, so that's pretty much it. Then we can have some cool animation using JSAP. So JSAP is a library to animate. And we can basically make the text scale, for example. So here I'm gonna animate it like that. So as you can see with the text. So I'm just importing JSAP. And then, okay, here I can change the mesh scale, make it scale on the y-axis only. So it's gonna up, doing that. See, as you can see, welcome. It's appearing like that. You can animate any 3D shapes you can do. So basically here we are saying the scale, change the scale from X is staying 1, 0. We can keep it like that. But 0 we are going from, the Y we are going from 0 to 1, sorry. This is the easing curve of animation. I like this Expo Out. I'm using it a lot. It's a nice animation, I think. And here is the duration of the animation. So it could be faster actually if you want, or longer. I think 2 is great. And then we can do the same for the shapes. So for that, we are just gonna do the same thing, but inside of a shape. So the first time we create the shape, we can scale the shape. So it's this mesh. And we can do something different. We can add some delay. So that's what I did here. Actually, I'm just gonna reuse the one from the demo. And here, basically, we are saying scale it from 0 to 1 in all the axes and add a delay. And the idea, this delay will be based on the index of the shape. So basically, when here we are creating indexes, we can do index 0, index 1, and index 2. And here we can save. Okay, so here as you can see, it's appearing but with some delay. So it creates this not welcoming effect in your website. So you can easily have this simple 3D scene in your website. And then you can just do classic HTML frameworks, anything you want. Cool, so we have this welcome. Yeah, and I think that's pretty much it. I think we can also now play with the mouse. So here we are using the orbit control, but you don't want the user to be able to do this, right? You don't want the user to be able to infinite scroll like that or whatever. So for that, we are going to, first of all, remove I'm going to comment the control. Okay, so now I can't do anything. But we also want to make it dynamic, right? So we want basically using the position of the mouse to change, to rotate. So basically we're gonna use the position of the mouse to rotate the whole group. Remember, we have a role group called container mesh. That's why it was there actually. And we can now make it move, make it rotate from the center of it. Okay, so for that, we have to go in the events and we're gonna add like a mouse move listener. So anytime you're using your mouse, I think we can keep passive actually. Anytime you're moving your mouse here, you can, wow, forgot this. Okay, so now we can create an object. First of all, an object here with x0 and y0. Not that if you're using TypeScript or anything, you can just put all of this. Actually, I think it's better. You can put all of these things here at the before the constructor of the class. So it's basically saying, okay, anytime you create this class, I'm gonna first create an object called container mesh that will be a 3D object, etc., etc. It's just better for understanding. And then, so we have our mouse. Now we have to get the position of the mouse. So to do that, we are gonna use the client X. But so let me explain. Basically, just you can copy and paste that. Basically, it's taking the position of the mouse divided by the width of the window and multiply it by 2 and minus 1. That means when the mouse is in the center, it's 0. When the mouse is at the very edge of the width of the window, here it's minus 1, and here it will be plus 1. So it's going minus 1, 0, 1. That's what we want. And the same for the y-axis. Okay. Then that we have that, we can rotate. We're going to rotate this in the renderer based on the on these values. So here. So MathUtils is from Three.js. You can import Three.js. Yeah, I talked about that already. But here we basically want to rotate this from 10 degrees angle on the y-axis and 10 degrees angle on the x-axis, but you can change that. So this is going from minus 10 to 10, so actually 20 angle, and minus 10 to 10, because remember this value is between minus 1 and 1. And here we are doing the same thing as we did for the rotation, remember? So here we're gonna rotate the whole group. So this is gonna create this effect. Okay, so that's what we want, as you can see here. So we have a nice 3D effect, really subtle effect on this. Then you can add like, here I added a gradient background. You can do a lot of things. You can increase the angle if you want. Then you can imagine like everything that is happening when you scroll. You can do whatever you want actually. It's really like, I would say it was kind of like a sandbox episode, almost a sandbox tutorial, because it's like just the basics of Three.js and you can play with it and do whatever you want. So I hope you guys liked it. I hope you guys learned something. And if you did, like, leave a like, a comment if you have any question, and you can also support my channel. That's it. I'll see you in the next tutorial. Bye.